I've been trading crypto. I've been trying to get more every time it dips low. I've been trading crypto. I've been trying to get more every time it dips low.
Welcome to the ChainLeak podcast. I'm your host, Joshuwa. Today's episode is XYO, Introduction to XL1. Today's guest, Arie Trouw. Welcome to the show, brother.
Thank you, Joshua, for having me on.
All right, so give the listeners a quick introduction to XYO and what you guys have built as far as DePIN for the industry.
Well, we started XYO, or we launched XYO in 2018, and that was a protocol to make data structures and disparate ledgers basically for data for DePIN. So you could have, each device can have its own little mini ledger of blocks, a little blockchain that goes on there, and they can communicate with each other. And the reason for it was because we're obsessed with sovereignty, provenance, and permanence, really, are the three things which I believe is what blockchain should be providing for you. And without that, to say, well, why are you even using blockchain? So you want sovereignty, provenance, and permanence. And so we provided those there. The one thing which we didn't have at the time, and until we have XL1 or the XYO layer 1 now, is we did not have the ability for people to communicate those things to each other and be able to process transactions between each other. So we added XL1, which is a new token, which is the gas for the XYO layer 1. And that one basically, it allows people to, for example, put requests on there for witnessing information in the world or processing data or storing data, and then they can recall it from there as well. And so we are basically, we have a tangle of chains, which is XYO, and then we have a backbone of chain, which is our XYO layer 1, which is the backbone of communicating through, kind of like an enterprise service bus.
Okay, now let me stop you there. You guys have the Coin app. Now, does XL1 tie into the Coin app at all? Or is it going to be something, a new programming language that you would build out infrastructure for?
Well, we use XL1 or the XYO layer 1 network right now for some of the coin functionality. So
Okay.
we've historically used it, XYO technology for that, but now being able to store data on there and have queries. For example, we're working on leaderboards and any sort of shared data that we want to present to people to put that on that chain there. And so the thing which is really cool about XYO layer 1 is the amount of data you can store on it is pretty much infinite, because we don't actually store the data on it. It's more of a metadata chain where we store the hashes of it and the time when it was put on there, that sort of thing. And then we store the actual files in a file repository. We call them data lakes. And those data lakes could be IPFS if you wanted to be there, like Filecoin or storage, or it could be just a Mongo database, for example. And so we can store like a large images or videos, or even like the leaderboard, which changes over time. We can store that in these different storage things, but then have the history of it recorded on the XYO layer 1. It works kind of like GitHub does, for example, but it's a shared GitHub for everybody to use.
Now, that's a unique way to look at data verification. Instead of having large terabyte files, you could store a terabyte worth of data in an IPFS and tie that into a block hash that verifies, would it be ownership or would it be creation? What would be the verification you would be doing for a file?
Well, the most basic thing is ownership and verification of when it was created. So you can't know that hash until you actually have had that data. So if, for example, if I want to declare that I started using a logo or a phrase for my company, I can say, well, here's a file which has all the information in there. But I don't want to make it public. It stays private. I put the hash on there. And then 2 years later, if someone says, well, I want to use this name. And you're like, no, I used it 2 years before you did. I can say, well, here's the hash that proves I had it then. And here's the file that matches to that hash. So I can selectively make that file public, but still retain the date and the verification of it from 2 years ago without having to have made it public 2 years ago. And so having off-stored data basically be verified on-chain or off-chain data sort of on-chain is something that's very, very important. Also from a scalability standpoint, I think that's one of the biggest problems with a lot of our chains now, where everything has to be stored on Ethereum or on Solana or that. and it makes them so large, and it becomes one hard drive that everyone shares, which is problematic.
Are you guys building the program infrastructure, or will it be third parties building on top of XL1?
Well, we build the implementation of the primary protocol. So we're building the SDK, the code for the producers and the nodes and those sorts of things. Third parties can build, for example, adapters. So if you want to have an archivist that goes to Cassandra or a different database that we don't support, anybody can make one of those and say, well, here's an adapter to be able to go and get data from there. Also, if somebody wants to port it to a different language like Go or Rust, they can do that. So our goal primarily is to make the protocol work the way it's supposed to, and have these different nodes running, and have the chain running the same way that Ethereum does that, but then have third parties potentially build on top of that and use that technology to do things.
From a developer standpoint, if I was building an application and I wanted to store the data in a different place,
yeah, you can store wherever you want to, because you take the file and hash it. In theory, you can hash it, put the hash on chain, and then throw it away, and then you can never prove that you had it because you don't have the data anymore. You can put it on S3 if you want to. You can put it in Mongo, as I said, or on a hard disk. The key to a data lake for us, though, is being able to recover that and find that somewhere. So you want to be able to map that hash to like an IPFS hash or to a place on S3 and be able to get that back. So we provide those features. And one of the things that's nice about the way our SDK works is you can like plug a data lake into the SDK. So when I write something to the chain, I have two connections basically. I have a connection to the chain architecture, which is where my hash is going to go and the next block in the transaction is going to go. But I also have a connection to the data lake. So all the things that aren't supposed to go on chain goes to the data lake automatically. And all the things that are supposed to go to the chain goes to the chain. So it feels like you're writing to a chain that has massive storage, but you're actually writing to two things at the same time. So it makes it very convenient for a developer.
Okay, now to elaborate on the idea I was just talking about is I just released 5 songs on Spotify, Amazon, all the different streaming platforms for music. But if I wanted to develop a platform for music and I wanted that data stored in a specific place for my entity, how would I still tie back in to XL1 to verify on chain each? Would it be individual songs? Would it be per artist? What would that type of layout look like?
Well, what you can do is you can make the metadata yourself. So you can make a payload that goes onto our chain that's got a specific schema. So it could be your domain name dot music dot artist or whatever it is.
Yeah.
So how you structure that's up to you, and then it has the hash in there for the specific file, which is the music file. And so what you do is you take the WAV file or the any of the files you want to say, well, I'm going to hash that, and then take that hash and put it on chain. We have a simple tool. We call it digital artifact. Sorry.
Okay.
A digital artifact basically is you can take anything and drop it on the website and say, I want to take this file, whether it's a PDF, a WAV file, a video. It just takes the client side, it hashes it, gets that hash, and says, okay, I'm going to store this hash online. Where you store that file itself is up to you. So getting it on there is actually quite easy through these tools. Which says, the retrieval of it later on when you want to prove it, and say, well, 3 years later, someone's like, hey, you have this hash that says I have some music I made 3 years ago. Well, what music was it? And then you can pull it up and say, well, here it is. And by the way, you're using my beat from it, so I want to, a cut of your revenue.
Royalties, right? You know how it goes. Okay, so let's look at the infrastructure of XL1 for the average end user to understand. What are the different data layers to XL1?
Well, really, as I say, there's the data layer which goes into the data lake, which is the actual file storage, and then there's the metadata where we store it in there. And to the user, we also have an explorer where a person can go there, kind of like Etherscan. Yeah. So if a person wants to say, well, show me your transaction and prove that it's actually on the chain. So I can just send you a hash and say, hey, I made this hash 5 years ago, and then you'll be, oh, how do I know you made it 5 years ago? What's it mean?
Right. Yeah.
Right. But if you send me a link to our Explorer, you can say, well, this was made in block number, whatever, 184,000, and that's the date on that was 5 years ago, and because you can tell the blocks, it's immutable at that point. So we can prove that this thing, there's no way for this thing to have been made recently. And so the important layer there is the actual network to be able to have that provenance. So the provenance is the fact that you signed it, that your address signed this. The permanence is the fact that it's been stuck into a certain slot or a certain block of this blockchain. And then the sovereignty is the fact that you don't need to trust like Facebook or Google or Apple to store this in the cloud and then just somehow swear under oath that this was stored there 5 years ago, right? Or their file date on their hard drive was 5 years ago. It's completely sovereign for you to be able to do this without having to have any trust from any other company or entity.
In the long term, will XL1 stay EVM compatible for end users' wallets that they already use?
Well, we're not currently EVM compatible from the standpoint that we don't run EVM code on our system. We have discussed potentially having an EVM sidechain for our chain. But generally, when we want to run EVM things now, we just run them on other networks, because there's already millions of EVM networks. However, our signatures, so we decided to use the same algorithm as Ethereum, the classic algorithm, to make our signatures. So our signatures are completely compatible to Ethereum. And so if a person wants to use the same kind of wallet, they can. And so
that's what I was trying to understand. So the 0x wallet would still work. That doesn't necessarily have to be EVM compatible?
Correct. It's just a way for us to be able to verify that it was signed by a certain address. So if you give us a signature and you give us an address, we can get the address that signed that with a signature and see if it's the signature or the address which you say it was. So to prove that you signed it. So we're compatible. For example, Solana signatures are different than Ethereum, but they have an EVM. They have an equivalent of a EVM that runs. Okay. So we're not a blockchain from the standpoint that we actually run complicated code on our system. So we don't have like one shared CPU for everyone and one hard drive for everyone. Everybody does off chain their own thing, but then they store the results of those on our chain. So we believe it's a much better model for blockchain in general because it's much more sovereign and it's much more parallelizable.
Okay. Yeah, no, that was something that I must have misunderstood. Is I always thought the 0x addresses just came with EVM compatibility. Is that usually the standard in the industry, or is it more based on them signatures?
Well, the 0x addresses that Ethereum uses, that's their address protocol. So how things are signed. Their EVM platform uses those as addresses. So their EVM platform basically is dependent on their signature process, or for those classic based signatures. But we can use those signatures without having an EVM, if that makes sense.
Okay,
so EVM needs the signatures, but the signatures don't need the EVM.
Yeah, no, this is wild. Okay, so give me an example of the starting of an XL1 address.
It's the same. It looks just like an Ethereum address.
Got me. That's what I was trying to get at. So the 0x, you can use the same exact wallet you've been using for 10 years. That's what I was trying to get at.
Well, you can use the same key phrase. So if you get the key phrase out of your MetaMask, if you want to, you can take that, put it in our wallet, and then you can have them there. We generally don't suggest people do that because now you have two secret phrases in two different things. And so you double your... So we always suggest to make their own in our wallet, and then they can just transfer stuff back and forth and that sort of thing. So you can't like just transfer Ethereum, for example, to XL1. So there's that's a bridging concern because they're stored in a different place.
Yeah.
But like for example, you can transfer XL1 to Ethereum, and then there's wrapped Ethereum basically wrapped XL1 on Ethereum, and then you can take it to exchanges there and that sort of thing.
Yeah, no, that's wild. Okay, so let's look at the block infrastructure. Is it different than anything else on the market, or is there something comparable?
Well, it's quite a bit different from the standpoint because of the fact that we don't store all this code and everything on chain. We didn't have to go and compress it by making it all binary. So if you look at the blocks of Ethereum, it's really compressed into these data structures. Our blocks are smaller for the most part, where we just use JSON to actually store them. So they're much more easily readable by a person. They can just look at the JSON structure and say, well, here's what these things say. And then the previous block hash is just a hash of that JSON. We did have to do some interesting things to hash JSON, because JSON could be like, for example, fields in an object could be in different orders. which will make the hash different. So what we do is we process that JSON, we sort it, and we make sure it will always hash the same way. So it doesn't matter what kind of JSON you give us, we'll always convert it into properly sorted and properly white spaced JSON, so that the hash will always be the exact same and predictable between hashes. But we use JSON as our primary structure to store that. But the previous hash, a blockchain is defined by the fact you have a block with the previous hash, which points to the previous block, and so on and so forth. So that's very similar to almost all the blockchains out there.
Okay, so the file size of a block is what sets you guys apart. Now, by having the hash itself smaller than, say, Bitcoin or Ethereum or Solana, are there any other blockchains with a comparable block size?
Well, our blocks end up being probably
Kilobytes
similar
of data?
size to, sorry?
Kilobytes of data?
Well, it's kilobytes, yeah. So it's similar size to, like, say, Bitcoin, but you can actually store, or it seems like you're storing a whole video file on there, for example, because the video file goes off chain. But you can access it when you're looking at it as if it's on chain. Where if I wanted to store, say, for example, a 1 megabyte image on Ethereum, it'll probably cost me $100,000 in gas to be able to store it there, and it's probably larger than the maximum block size anyway.
Okay.
But since we don't have to put it in the block to actually store it, we don't have to worry about it making the block too big. And so it allows for us to have more things in a given block. And so our transaction rates can be higher, our number of transactions per block can be higher, and those sorts of things.
Now, when it comes to the XL1, do you guys have a faster transactions per second, maximum transactions per second? And what does the speed look like of this new network?
Well, in a controlled environment, we've gotten the speed up to sub 1 second blocks per second. But in our live setup, because there's network latency and stuff like that, we generally see around a maximum of 3 or 4 seconds per block. And then each block can have thousands of transactions in them. So the transactions rates per second could be thousands of transactions per second. We haven't seen an upper limit for that yet, but in theory, you could have 100,000 transactions per block. If you have one block every 3 seconds, that's
300,000 right there.
33,000 transactions per second, which is pretty high compared to Ethereum.
Now, when you look at industrial use for XL1, what types of businesses do you think would use this type of infrastructure?
Well, anybody who wants to use, in my opinion, any blockchain, but specifically ours, is people who want to add metadata to their data, which gives them provenance and permanence and sovereignty. So you don't want to have to have somebody swear that this was a certain data was created or owned by a certain person and that sort of a thing. And you also want to be able to know it was created at a certain date. So, for example, a supply chain is something which commonly comes up when we talk about our system, where you can have all these different things. Like, say, a truck is going through the country, it can sign all these different checkpoints where it reached different warehouses and so on and so forth. So you can see your tracking information for a package, for example, but it could be sovereignly stored on chain. So if a person sees it, they know that, like, it wasn't deleted. So I've had that before where, like, I see my tracking information and then it changes, and you're like, well, it said it was in Anaheim, but, like, now it doesn't say it was in Anaheim anymore. So was it in Anaheim and you deleted it, or, like, what's going on here? Where if you do it this way, like, it can't change. It could be like, well, it went to Anaheim, left, and went back, perhaps, or whatever the history was is permanent. So anybody who wants to have that transparency and that permanence and the provenance would use a system like ours, which I think more and more companies are coming around to realize that really gives you customer faith. Customers like to see that transparency as opposed to, let me just trust to see what you do. Because we've seen companies like Facebook, for example, it's like, oh, let me trust them with all my photos and everything. And next thing you know, they're selling it to Cambridge Analytica. So having things which are in their own data lake and in a sovereign solution is something which I think a lot of companies are realizing is important.
That's another thing I think about is UPS, FedEx, Amazon, USPS. All of these different entities could sign a verification hash every single time they put something in your mailbox or drop it at your door. When they snap that picture, they could tie that picture back into the chain and verify it with a hash to where, okay, this delivery driver, he did 50 stops today, and here's all 50 of his verifications. Now you tie that out to the whole country. Now you're talking about 50, 100,000 workers every single day doing 50. Now we're talking about those bigger numbers that 400,000 transactions are happening. That's the type of numbers I'm thinking. Like when you think of big infrastructure using this type of technology, that's the perfect example I see.
Yeah, definitely. That's what I see also, and that's why the key to it is performance and storage. You have to do it in a way that's different than our current blockchain solutions, because if you're doing it at that volume, to actually store all that on a shared ledger, it's just not practical, right? You can't put all that data, like the photo they take, for example, of your box sitting on your doorstep.
Yeah.
You can't just put that on Ethereum or on Solana or on any of those networks. You have to store that somewhere else, but you still want to have a reference to it that is completely verifiable.
Yeah, no, that's crazy. And then you think of the timestamp on the hash. So it verifies, okay, that was supposed to be delivered by 3 o'clock and they didn't deliver until 3:15 or 4 o'clock. Now you have to check on that driver and see what he did for that 20, 30 minutes. And they could have more unity in their drivers knowing the specific actions. They ain't out here joyriding. They had to stop and get a Coke. You know what I mean? They have to have answer for why they were late on the delivery.
Yeah, but I think it benefits both the driver and the company, because the company then doesn't have to worry about, does the driver like lie about this or check it in there and that sort of thing, because they have proof. But the driver also gets protected, because when they go and deliver something and they scan it and it gets permanently put on the blockchain, and if then the company's like, hey, you stole that or you didn't deliver that, they can be like, well, here's my proof, right?
Yeah.
And so to me, security through transparency is something which gets very undervalued. People think that privacy equals security, and I'm actually an anti-privacy advocate. It's a very strange term. I like privacy for certain things, like key phrases and passwords and stuff like that, obviously. But the idea of privacy making us a more secure country or a more secure nation or a more secure world is, to me, is the opposite. The more transparent it is, people won't do things that are bad if it's transparent. Like if like tattoos on your arm that you stole gum every time you steal gum, like you're not going to steal gum, right?
Right.
And so the more transparent the world is, and the less privacy there is in a weird sort of way, the more security there is. And so this is kind of equivalent, where there's more transparency between the company and the driver of what actually happened in the real world. That's why we call ourselves a reality engine. And so it's the interaction between blockchain and the physical world, and how do you memoize that on the blockchain so people can rely on that as a record.
That's so cool. Now, for the blockchain itself, XL1, how does an end user or an entity get involved in hosting a node on the network?
So right now, what we're doing is we're hosting the initial nodes. There's different kinds of nodes we have. So we have like the full nodes, which are block producers, and we have verifying nodes, and we also have data nodes where we store our data lakes, and we also have APIs, which is kind of like an Etherscan, where basically it'll get information for you and store that. So right now, the ability to actually host an API is something which people can do. They can take that, point it to the thing, and they can actually it'll give you information about that. We're going to be rolling out the public version of the producer nodes, being able to do that in the next I think 3 to 6 months. We have to make sure it's extremely secure. We have some partners that we're working with to host them as well, but not just an average person can download it at this point, because we want to make sure it's not violatable just yet. Same thing with the verification ones. And then we also have what we call witnessing nodes. They're basically, so the Coin app really is a witnessing node, and so it's the one that gathers data and then takes that data and stores it on chain. And then you can use that to actually see what happens. That's how Coin works. It's like, well, we ask you to do something, to drive around and geomine, or we ask you to go and take a picture of a storefront or whatever it is.
Yeah.
That then gets stored and put on our chain. So those are all nodes that are our data collection nodes. Those are the things which people can do today. They can install the Coin app and basically become a data collection node for the XL1 network, or the XYO layer 1 network.
That was the next thing I was going to get at, is while you were talking there, I'm thinking about a mobile aspect. Outside of the Coin app, will you guys have a different type of application for witness nodes on the XL1 platform?
Yeah, so as well, right now we do most of it through a web interface. So you can do a web experience on mobile to be able to do these things, because we can do a lot of the hashing and stuff in there. We can take photos of things. So we're first coming out with the mobile enabled web experience for it, but
Yeah.
we have an SDK that's in beta right now for iOS and for Android. So people, if they want to include this actually in their native code for those platforms, they can also do it there, and they can send data to witness it. So the data collection and data viewing aspect will definitely be possible to be put into native apps soon by third parties. And then the web version of that is something which they can do inside of a web view or just in the website if they want to right now.
Yeah, I was thinking about APKs all day. I'm an Android guy, so sometimes I download, sideload APKs that are betas, and I test different things. So yeah, definitely when you guys have something like that, I'd like to check it out for sure.
Okay, definitely.
You guys also have something called step hashes for the XL1. Can you explain what that is?
Yeah, so something which we did, a traditional blockchain has the previous hash in there. So that's how you know that this is a blockchain. So, but if you want to go back, say, 100,000 blocks, you have to walk 100,000 steps to get there, which becomes problematic, right? It's like, well, it's going to be a little while for me to get there. But so if you want to do a balance, for example, you have to go and check the balance for all those different blocks. So what we do is we made a thing called step hashes, which is a separate section of our block where it has a previous hash for 7 steps to go, for example, a previous hash for 31 steps to go, a previous hash for all these different larger steps. And so it's a way for you to actually jump back in the blockchain and still know that it's actually part of the blockchain. So you can actually traverse the blockchain substantially faster because we have about 7 different layers of these step hashes of increasing size. So for example, when we want to get a balance, what we do is we jump back the largest step we can and the small. So we can only have to check like 12 different steps to see what your balance is. And then we just cache those values there. We don't have to go and calculate it all the way through. So we really built rapid traversal into the protocol itself, as opposed to having to do it from an outside system. Like Etherscan lets you do that, but it's done because it's indexed them all. And it's okay, well, I can jump from number to number, but there's no way for you to actually, given a specific block, you can say, well, this was definitely in this chain, even though you don't have to have all the blocks between those. So you don't have to actually have the entire blockchain to verify the inclusion of a payload or a block in the chain.
Now, for looking at the balances, if it jumps back, let's see, 500 blocks and no balance has been changed, does it just mute out them 500 that it just skipped and go another 500 back and see if there's any balance changes in them 1,000 blocks as one, just skipping 500 at a time? Is that a good example or no?
It is kind of, well, there's 2 reasons to check a balance. One is to know how much you have, and the other one is to make sure you have enough to actually do something. So It's like sufficient balance is different than absolute balance. So absolute balance we do by storing summaries of all these different steps of all the different people who are in there. So we can go back and just check all these summaries, add them together, and then that's your balance. One thing that's nice about balances is that you know that they can't go negative because of how blockchain works.
Right.
So if I ever have a positive balance, I know I have enough. Doesn't matter what happened before then. And so if I can go back and say, okay, well, in this past window, I've reached a point where I've gotten some XL1 from somebody and I haven't spent it all yet. I know I have at least enough to spend what I want to spend now. I may have way more from the past, but we don't need to go all the way back.
Verify
because as soon as we
everything
know you have
else.
enough, we stop.
Okay. So it could go however many blocks back it has to. Say I want to send 10,000 XL1. You just need to go back enough blocks to verify I have 10,000 XL1 to send.
Correct.
And then you
or
stop.
More. We don't care if you have more, but at least 10,000. And because it's unidirectional, we know that there's no, if you could have gone negative, then it's possible you don't have 10,000 now, even though, you got 10,000 after that because we were negative. But since you can't ever go negative, it means that we
Right.
know that you can do a partial scan there, which is really convenient. Because one of our goals also is to make it so that all of our different nodes can run with partial data. Because one of the big problems I've had with, whether it's Ethereum or Solana or all these is like, well, if you want to run a node, it's like, well, first thing you got to do is sync the entire history of mankind from that chain, which is a huge data set. And often you have to have these giant, giant computers to run to actually process those. So our goal is to make it so that you can actually run a node, whether it's a producer or a validator or an API for this thing, with a much smaller set. You can say, well, I just want to keep the last, say, 10,000 or 100,000 blocks.
Yeah, right.
And there might be some things I can't answer. If the last time we got a balance was way back then, I might be able to say, well, I don't know if you have enough for this or not. So maybe go ask somebody who has a bigger one. But if I can find your balance in that window, I can say, well, you have enough, so it's good. So that allows people to participate as nodes without having to make a very large capital expenditure for hardware.
Are step hashes unique to the XL1 blockchain?
I have not seen step hashes used before on other blockchains. It's possible that they do. So I don't think I'm the only person that comes up with good ideas. But we're not basing it off of anything else out there. But I wouldn't be shocked if they do that somewhere else.
Okay. Now, what are bound witness trees?
So a bound witness is the way that we store data. So for example, a person could multi-sign a bound witness. So a bound witness is if you take multiple payloads and then you say, well, I tested these payloads being correct. But a bound witness, the reason it's called a bound witness as opposed to just a witness, is if you and I are in the same place, we can say, well, we're going to take this set of data, we're both going to sign it, and they're going to go into both of our personal blockchains, and then we can also stick it on the shared blockchain. And the way I describe this for people often is like, imagine if you had to go through life and every time you see somebody, you take a selfie with it and both of you guys sign it and you both get a copy of it. Now I can prove everyone I've met throughout the last 10 years I've done that if I were to take a selfie of everybody. So a bound witness is a co-signed payload basically that more than one party has attested to, but it also ends up in their own personal chains. So it's kind of like remembering the interaction between two entities that's on our network, whether it's two people or two DePIN items or devices. And so that's the kind of the fundamental structure of how our blocks are. Our blocks themselves are bound witnesses, and the transactions we put in our blocks are bound witnesses as well. And so the reason we call it a tree is because one bound witness has another bound witness in it, and then those can have more bound witnesses in them. And it's kind of like so many folders on a hard drive, right? So you have as many folders as you want to, but they all roll up to this one hash on top and say, well, that hash goes into this block. So you can have a very complex structure of bound witnesses if you want to, that you just load the one hash into our shared blockchain, keeping it very small again.
Like a root system for a tree, basically. Mm-hmm. Okay, now I'm trying to think of other use cases. You guys are big in the DePIN sector of the blockchain industry. What other types of DePIN products would you like to see build on top of XL1?
Well, as I said, the primary thing is you have to ask, where do we need provenance and permanence? And so I think a lot of different companies want that now. Take, for example, a meter reading for your water meter or for your gas meter. Being able to say, well, this was read at this time, and then you put it on blockchain. So you end up with provenance and permanence. Hardware devices can be made so you use LoRa or one of those things to transmit that data to somewhere. But the goal would be for more and more devices, whether they're phones. Right now, our primary edge device, should I say, is a phone because it has really cool sensors on it. It has a lot of things it can do, and it moves around. It's got GPS. But the more and more devices we can have in the world, which actually have our protocol running on it, that can do the same kind of thing that a phone can do, but potentially some of them are stationary and some of them are moving, and they can interact with each other. So anybody who wants to have a ledger of what happened in the real world, whether it's temperature readings, for example, in the rainforest, or rain level readings in the rainforest, or one company I talked to was they wanted to have microphones on there so they can record or sense chainsaws. So if people are illegally logging in the rainforest, it's like, well, how do you record that? So it's like, well, every time this thing hears that, it's going to put this on the blockchain and say, hey, within a certain radius of this device, I heard somebody with a
Chainsaw.
chainsaw.
Yeah.
Let's go and check out who that was and figure out who it was. Or even better, if there's a way to have a camera there, I can take a photograph of it, almost like a traffic camera. So, and you can make that
With the
permanent.
traffic cameras in my city specifically, I swear they put one on every street corner now. So you have that type of data, and it wouldn't necessarily be anything bad, but you have license plates for every single person in the city, and you have location data for everybody in the city. If somebody was going 5 miles over, like different things like that, I feel like they're overstepping. What do you feel about that kind of outlook?
Well, that's already happening, right?
Yeah, there ain't no
so people
stopping
already
it,
get
right?
those pictures. So your privacy is already gone. And so I look at it as we can't get that genie back in the bottle at all.
Right.
So we might as well make it so it's accessible to other people. You obviously have the bad uses of it, where if somebody wants to like stalk somebody and they can say, well, where are they going, so I can see where they are.
Know exactly where you're at, right?
Yeah. So that's one of the reasons we like the privacy aspect of our chain, where I can put a hash on there, and the photo goes into a private data lake. So if say take the camera, the traffic camera, for example, they'll send you the hash in the mail and say, hey, we know you ran this red light. Here's the hash for it. And you're like, well, I don't know what the hash is. Prove it to me. Send me the photo. But like, okay, well, we'll send you the photo. But those can be locked away, as opposed to right now what happens is that's just in some Mongo database. So there's some IT guy sitting there going through the photos and saying, hey, I recognize that celebrity, and that's not his wife with him or whatever it is.
Yeah, right.
So the idea there is you can actually lock away data in more securely by just having the hashes on there, and then the total, which is like, well, you ran a red light. And then only when it's necessary, expose that data to the person who has the right to go and ask that. So separating the data from the permanence and the provenance, to me, is really the magic of XL1, as opposed to trying to stick them all in the same box. If you stick them all in the same box, it's like, well, it all has to be public or all has to be private. It's all accessible to everybody or nobody. And so really tearing those two things apart, to me, is what makes our chain special.
Another thing with the cameras that I think about is from the celebrity perspective. If this type of data is stored in a third-party server somewhere and a bad actor wants to get access to that, say they want to infiltrate the system for Los Angeles, and they want to find out what type of cars these celebrities are in, or who's their bodyguards and where they sleep at night, they'd be able to obtain this type of data that's being shot on all these different cameras. So how would they avoid that? You're saying with XL1 they could avoid that?
Well, it's easier to store that data separately from the actual metadata that goes along with it. So you can separate it. You can even encrypt it at the camera level. And so have that camera basically encrypt that data before sending it to a server. And as long as the camera says, well, you ran the red light, it doesn't even have to be able to be decrypted unless you really request it to be decrypted. So having a one-way encryption where something can encrypt it, but the key to decrypt it is protected by somebody else somewhere in a more secure location, makes it so that your average IT guy can't sit there and just go through S3 and look at photos, right? Where I'm sure there's a lot of guys at Facebook who can just sit there and page through random photos on their server somewhere, even though they're not really supposed to, because they probably store them in plain text or a plain view on large databases. So it doesn't make the data secure as such, like for celebrities or for these sorts of privacy things, but it gives you the tools to do that.
Another unique aspect of the XL1 blockchain is the rollups aspect. Can we go into that a little bit and how your rollups are different than what Syscoin is doing on top of Bitcoin? What do your rollups look like?
Well, our rollups are really meant to be used internally to XL1 primarily. So it's like we roll up our own data to be able to get it to be smaller and stored on there. But we basically natively support rollups in our system. We haven't really done a lot of rolling up other people's data from other chains, like Ethereum data or that sort of thing, into our system. But we definitely have the ability to do that if someone wants to roll that up there. So it's a prime technology for just building rollups for whatever you want to, if you wanted to do that. But we primarily built it for our own use and for our own efficiency for our system. But the concept of rollups are great.
Okay, so it's not the same type of roll up that these other blockchains are building on top of other networks. It's specifically for XL1.
Yeah, it's for external data primarily. It's not really to roll up other blockchain data, even though other blockchain data is still external data. But we like to roll up other things, like, say, for example, your meter reading history or your driving history or whatever it is.
I'm so sorry. There was a blog article, or it might have been on the GitHub, but you guys had the different sections of the new aspects of XL1. And one specific outlier was proof of perfect. Could we go into that a little bit and what that means?
Sure. Well, first of all, I think we came up with a pretty cool name. So I like it. Everyone loves the name Proof of Perfect because everyone likes perfect and they like proofs. But the idea of Proof of Perfect is to come up with a way to determine what is the head of the shared ledger. And so Bitcoin did that pretty easily. Bitcoin is just like, because everyone's using hashes, whatever's the longest one is the best one, right? So it's all chains have an algorithm that I call a best head chain, where it's like, well, you have uncles, and well, which one's the best, and should I build on? But that becomes difficult. You can have like a centralized arbiter, or you can have a panel of arbiters that decides which ones are finalized and which ones are that. But our goal is to determine the best chain in using certain heuristics, and so we call it perfect because we want the most perfect chain, kind of like the most perfect union for or a more perfect union for the United States. And so we include things like how much diversity there was in creating the chain. So if there's an uncle and like the last 50 blocks were all made by the same producer, like that's not as good as like, well, a whole bunch of different producers made these things, because like, well, what's going on there? So we come up with a whole bunch of heuristics where we're like, well, given this set of data, this is how we would like score this and determine if this is the best uncle. And so a way for us to be able to objectively score different chains, and everybody pick the same one given the same set to be the head or the one that we select as opposed to the uncles, and build off of that one without using something like a hash or a hash rate, which Bitcoin does, or a gadget. Yeah, some of them use they call them finalization gadgets and that sort of a thing, where it's like, you can come up with that. But it's a form of a finalization gadget, but it's a sovereign gadget because everybody can run the same algorithm and determine which one's the best.
Now, is that unique to XL1?
Our algorithm is definitely unique. The need for an algorithm or a way to determine what's the best head is not unique. Obviously, everybody needs that, but the way we went about it, I believe, is more novel than most of them out there. Most people kind of either, because there's truly sovereign, and then there's consensus, which is a way to take 10 different validators, and if they all agree that this is the best one, that's the best one. So, which is still good. It's a lot better than something completely centralized. And then beyond that, you can go to things like round robin, where you just pick one guy to decide which one's best. The sovereign ones, like Bitcoin, for example, is very sovereign because anybody can look at it and say, well, whichever is the longest one is the best one. The downside of that for Bitcoin is eventually the quantum problem is going to happen for them. So if I can go by and say, okay, well, I can make this super long chain with my quantum computer that happens to be the longest one, I've now rewritten all of history, which is bad. So they're going to have to figure out how to deal with their the longest one's the best one algorithm when it comes to the point when the statement of the majority of the world's hash rate has been used to make this, because that's what they rely on. That there's, for you to actually change it, you have to overcome all the rest of the hash rate in the world. If that ever fails, that's a problem for them. So we didn't want to do that. Well, we can't do the hash rate thing because that's kind of Bitcoin's thing, and for us to get enough hash rate to actually make sure it's secure, it's impossible. There's a staking aspect of it. There's which goes into our algorithm. So it's not just proof of stake. It's more than that. But our goal is really to do a non-consensus based sovereign solution for what's your best head, and it's a non-trivial problem. And I think it's better in many ways than even the Bitcoin approach, and it's definitely better in non-sovereign approaches.
When it comes to the XL1, XYO layer 1 blockchain, the data itself, is that interchangeable between chains, or is the data itself stuck on XL1 and the token itself can be wrapped and interchanged between chains?
Well, the data can go to other chains also. Obviously, we can send a token there. The data can be sent to other chains, but in cases like Ethereum, if we have data which is large, we can bridge it to Ethereum, but it's going to run out of space in their block. So the thing which we've solved is, well, you can have this large piece of data. I can write it there for you, so it costs you a fortune in gas to get it there, and so and they can also validate our hashes. So one of the reasons we picked the same algorithm for the wallet as Ethereum is in a smart contract on their EVM, we can send them a datagram and say this was signed by this address, and then they have a built-in way to go and confirm that because they can confirm classic signatures, right? So it's really convenient for us to be able to have our data used in Ethereum. But size restrictions is is really a problem. They can have the reference, and we can put the reference on there, which is the easiest thing, like just the hash, which is what we would do in most cases. But it's kind of like an NFT where the picture for NFT is usually stored in IPFS or somewhere external to Ethereum.
Yeah. Okay, so when it comes to multi-chain interoperability, what do you envision for XL1?
Well, XL1, I kind of view other chains as part of the DePIN infrastructure, right? It's physical infrastructure, and being able to communicate between those is the same as kind of communicating with phones and other devices. So as long as there's smart contracts on all those things or adapters where you can go and pull information from our chain and put it on there, you can actually communicate across all of them. And I think that XL1 can be the nexus actually to communicate between chains and pull data from Ethereum and send it to, say, Solana, for example, because we can normalize that communication between those there, because we can actually witness it on different chains. As I said, there are limitations like speed limitations and size limitations, so we can't do magic things with other chains. But making things that are interoperable via XL1, I think, or XYO Layer 1, is something which we'll definitely see a lot of.
That'd be cool. Just listening to you right there, cross-chain witnesses. That'd be a cool example for sure.
Yeah, well, we do that right now. One of the things we store in our blocks is we call it a time payload, because we need to synchronize blocks between Ethereum and XL1 and also the epoch. So what we do is when we make a block, we store on there, well, what's the current block on Ethereum? And so that way, when we have to go check our staking, for example, which we do our staking on Ethereum right now, we can say, well, between this block and this block on XL1, how much stake did you have? Well, what we have to do then is say, well, on Ethereum, which blocks were those on Ethereum, and then check between those two blocks on Ethereum to see how much stake you had. So mapping time. So I refer to like the block number as time on a blockchain, which is really what it is. That's the time going along.
Right.
So we can basically synchronize time between our blockchains and the physical world, which is an epoch number. And so we're in the process of adding even more time witnesses to our time block in our blocks, so we can have Solana on there and all these different ones. And that way, we at least have a record of at what point in time where, at this snapshot in humans time, or for example, what was the block number across all these different things? So you can synchronize what happens on it, which is synchronizing.
Go back and verify it. Yeah. Okay, now to close out the interview today, give me your outlook for the future of XYO and the XL1 blockchain.
Well, as I'm sure you're aware, I wrote this a lot of the software, and I founded this company, so I have a huge positive outlook for XL1 and for XYO. My passion really is to make sovereign and provenance and permanence-based technologies, and blockchain is one of those. Obviously, wallets are sovereign, but they're not really blockchain themselves. So I think what we're building is something which is more useful for actually everyday applications than most blockchain projects out there. A lot of blockchain projects out there, it's like yet another EVM chain, yet another DeFi that's going on. It's like they're doing this a little bit faster, a little bit cheaper than Ethereum. But besides, I'd say Bitcoin and Ethereum, no one has really come up with a practical, purpose, useful thing in the last few years. And I feel like the XL1 layer, or the XYO layer 1 chain, is potentially that next step in actually making blockchain deliver on the promise of making something useful and providing a feature for companies and for people that they couldn't do without it.
That's sweet. Well, this has been XYO, the introduction to XL1. Thank you for being here, brother.
Thank you very much for having me.
I've been trading crypto. I've been trying to get more every time it dips low. I've been trading crypto.